We obtain the following laws from the first 5 laws, and we will use them to solve the example number 2. We want to evaluate the following limits and justify each step. In part A, we can use the first one, the first law, and we will do limit of x approach to 5 of 2x squared minus limit of 3x when x approach to 5 plus limit of 4 when x approach to 5. So we are using the first law, and then we can move the number to the front. So we have 2 limit x approach to 5 of x squared minus 3 limit of x when x approach to 5 and limit of 4 when x approach to 5. So we go to the exponential. So what do we see in the exponential in law number 9? That means that we just put in the a into the x. So 2 times 5 squared minus 3, and if we don't have the exponential, we just plug in the 5 in the x. So we use law number 8. So just plug in the number in the x. So we get 3 and then 5 plus 4. So we use number 7 because 4 is a constant. Then we have 2 times 25 minus 15 plus 4. We calculate this and then we will get 39. In part B, similarly, we have the quotient, so we can separate the top and the bottom. So we use the law number 5 in this step. Now on the top is very similarly like part A, right? So we will just plug in, we can separate them, and then we plug in the -2. But since we already did in part A, so I'm gonna make it fast. We're gonna do -2 cubed plus 2 times -2 squared minus 1. And in the bottom is similarly, we just plug in the -2 at the x location. Then we simplify the top and the bottom, and we will get -1 over 11. So from this example number 2, what can we learn about this is that when we have a polynomial or we have a rational function, we can just plug in the number when we want to find the limit of x approach to that number. So just plug it in. So we have the property below is that when we want to find the limit of the f of x, for f of x is a polynomial or a rational function, and we just go ahead and plug in a into the function f of x if we want to calculate the limit when x approaches to a. So let's do the practice problem. Apply this. Example number 3. Find the limit when x approaches to 1 of x squared minus 1 divided by x minus 1. So it's really fast. We don't have to follow the step from law number 1 to law number 11. We just simply plug in 1 into the function. But if you notice in the function that that's something that we can simplify. If you do not do that, what happens is you plug in 1 in the x and it will give undefined. Okay, so we will simplify first before we plug in 1. We have on the top is x minus 1, x plus 1. In the bottom is x minus 1. So we can cancel and we get x approach to 1 of x plus 1. Now we have a polynomial. Then we use the direct substitution property. We just put in 1 in the x location and we got the answer is 2.